Hi, this is Naveen. Today we are going to read our chapter from a book Organic Chemistry by Pardeep publication, chapter 8 Synthetic Dyes part 2. Section 8.3 Dyes. A dye is a colored substance which can be applied in a solution or dispersed to a substance such as textile fibers like cotton, wool, silk, polyester, nylon, paper, leather, hair, fur, plastic material, wax, or a cosmetic basis, given its a colored appearance. Condition which a dye must satisfy. A substance can be used as a dye for a textile only if it is satisfy the following condition. First is it must have a suitable color. Second, it must be able to fix itself or are capable of being fixed to a fabric from the solution. Third is when fixed it must be a fast to light, resistant to action of water, soap, detergent, etc. during washing or to organize solvent during the dry cleaning, etc. Second, 8.31 Nomenclature. The chemical names of dyes are very complicated and hence trace names are more popular. These trade names often including one or more alphabetical letters with a number, whereas a number indicates the shade. Alphabetical letter refers to the color. For example, G for yellow, German Gabel equals to yellow. R for red, Rof is equals to red. Sometimes alphabet may also refers to some specific property, for example WE of fast to washing. German wash, chet. Sometimes the letter also stands for intensity of a color. For example, 6B stands for a deep blue color, close to blue. But sometimes these letters may have entirely different meanings. For example, Alzyrine, blue D. Here D stands for direct, which means it is direct dye for cotton. Section 8.3 Classifications of dye. Dyes may be classified into a number of ways discussed given below. First is natural and synthetic dyes. Since earlier time, man has been tried to accept dyes from a plants for using them to beauty his clothes. Such dyes are known as natural dyes. Two examples of natural dye known since nearly times are indigo, a blue dye, and algyrine, a red dye. Indigo has been a main procedure and known since it is times earlier time are indigo. However, natural dyes have only limited shades, hence nowadays most of these dyes are used as a synthetic dyes which have a variety of shades. Most of these dyes are aromatic compounds obtained from a coal tar, hence they are also known as coal tar dyes. Second is classifications of dyes based on their constituents. Chemical classification. In this system, the dyes are classified on the basis of chemical contribution of functional group to which a dye or own their color. Some important classes are azo dyes, nitro dyes, nitroso dyes, triphenyl methane dyes, anthraquinone dyes, indigo dyes, phenolphthalein dyes, alkyd dyes, etc. etc. Third is classification of dyes based on their applications. The application of a dye on a particular fiber depends on the nature of both the fiber and the dye as well. There are four ways in which a dye may be attached to the fiber through first covalent bond, second is hydrogen bond, third is ionic bond, and fourth is van der Waals bond. They all are basically a force of attraction. Based on the method of these applications, Dye have been classified into the following categories. First is acid dyes. The sodium salt of azo dyes containing sulfonic acid and carboxylic acid are called acidic dye. These dyes are applied to the fabric from their acidic solution and are used to dye wool, silk, nylon, and polyurethane fibers. The affinity of the acid dye for nylon is higher than that of other types of polycrepolate fibers contains a high protein of free amino acid. These do not have affinity for cotton and hence can't be used to dye cotton. Typical example of acidic dye are orange eye, orange 2, methyl orange and Congo red. Orange 1 is a versatile dye prepared by coupling diazotization of a sulfonic acid with alpha naphthalone. The orange dye, orange or the dye orange 2 is similarly obtained by coupling diazotization of sulfonic acid with beta naphthanol. Next is the structure and chemistry of or methyl orange and Congo red will be discussed in this chapter later. Our second dye is basic dye. These dyes are the salt of colored bases contains amino group, NH2 group or NR2 group as a exochromes. These includes azo and triphenyl methane dye. In this solution acidic, these amino groups from the water soluble contains cations which they react with anion site present on the fabric and thus gets attracted to them, modify or reunion forced nylon and polyester can be dyed by these dyes. Some common example of these classes are maybe aniline, yellow butter, yellow malachite green, discussed in a chapter unit later. Our third type of dye is direct or substituent substitutive dyes. These are water soluble dyes. As the name suggests, these are those dyes which can be directly applied on a fabric from an aqueous solution. These are most suitable for fabrics which can be hydrogen bond with their dyes. Thus, these are usually used for dyeing cotton, wool, silk, rayon, nylon. Congo red and Martius yellow are the two well-known examples of this classification of the dye. Dispersed dye. These dyes are water insoluble and are applied to the fiber in form of dispersion of a finely divided dye in a soap solution in the presence of some stabilizing agent such as phenol, cresol or benzoic acid. These dyes are used to dye synthetic fibers such as nylon, polyester, polyacrylonitrile fibers. These dyes belongs to the class of anthraquinone dyes and are suitable for dyeing synthetic polyamide fibers. Important example of dispersed dyes, that is anthraquinone dyes, are: first is Silton Fast Pink B, second is Silton Fast Blue B. The name of Sinton fast pink B is 1-amino 4-hydroxy anthraquinone and the name of Silicon fast blue B is 1,4-dimethyl amino anthraquinone. Our fifth part of dye is fiber reactive dyes. These are those type of dye which may contain a reactive group which combines directly with the hydroxyl or amino group of a fiber. Because the formation of permanent chemical bond between the fiber and the dye. The color of the dye fabric is fast and has a long time life. Cotton, wool, silk can be dyed with these type of dyes. Dyes which are derivative of 2,4-dichloro 1,3,5 triazine are the important example of a fiber reactive dyes. Insoluble azoids, insoluble dyes. These, these constituent about 60% of total dyes are used. These are the obtained by coupling of phenol, naphthenols, arylamines, aminophenol absorbed on the surface of a fabric with a diazonium salt. As there is only a surface absorption of the dye on a fabric, the color is not fast. These dyes can be used to dye cellulose, silk, polyester, nylon, polypropylene, polyurethane, polyacrylonitrile, and leather. An example of these type of dye is a para red. Para-nitro-benzene diazonium chloride reacts with beta-naphthenol in presence of NaOH. It gives para-red, and a side product is HCl. Azo also finds use in foodstuffs, cosmetic drugs, biological stains such as indicator in chemicals analysis. However, because of their toxic nature, these dyes are no longer be permitted to the dye foodstuff. Next type of dye is wet dye. Wet dyes are insoluble in water and hence can't be used for directly or dyeing. Therefore, they are first reduced to a soluble color from leucoform in a large vat with the reducing agent such as an alkaline solution of a sodium hydrogen sulfide. Under these alkaline conditions, leucoform develops an affinity for cellulose fiber. Therefore, these dyes are mainly used to dye cotton fiber. Indigo or indigotine reduction, it gives leucoform, and the leucoform oxidizes to give indigo. The cotton fabric of to be dyed in soaked in an alkaline solution and then oxidized to a insoluble color by exposure of air or by some oxidizing agent such as chromic acid or a paraboric acid. A well-known example of wet dye is indigo dye. Indigo sol. Oh, on another hand, it is readily soluble in water. It has affinity for a cellulose and then rapidly and quantitatively oxidize on a fiber with the formation of indigo. It is especially a suitable wool. Our last part of dye is moderant dye. These dyes do not dye the fabric directly but require some moderant. The moderant in fact acts as a building agent between the fiber and the dye. For acidic dyes, metal iron are used as a moderant, but for basic dyes, tannic acid is used as a moderant. These dyes are primarily used to dye wool. The fabric to be dyed the fabric to be dyed in first soaked in the solution of suitable metal salt moderant, and soaked fiber is and then dipped in the solution of dye. When a soluble colored complex called lakes are formed on the base on the fabrics, and the dye molecules are linked to the metal through which the covalent and the coordinate bonds form. The same dye can give a lake of different colors depending upon the metal is used. For example, algyrine gives red rose, Trusky red color with the aluminium ion, blue color with the barium, and brownish color with the chromium, violet with the magnesium, and red with the strontium ion. Chemistries of some important dyes. Section 8.5. First is azo dye. Azo dye constituent the large class of synthetic dyes. These chromophores is AR aromatic system joins to a azo group, and the common oxochromes are NH2, NR2, OH, etc. The usual method of preparation of azo dye involves the direct coupling reactions between the diazonium salt and phenol or an amine. The structure of azo dye is elucidated by the reduction of with essential to HCl or sodium hyposulfite, that is diethonite. When azo group is ruptured with the formation of primary amines which are identified. Azo dyes in presence of acidic medium, it gives primary amine. The azo dyes are classified according to their number of azo groups in a molecule, monoazo, diazo, etc. These are also classified as a basic cationic dyes and the acidic anionic dyes. Our section number 8.5.1, methyl orange. Helanethene. Synthesis of methyl orange is obtained by coupling of N and dimethyl aniline with diazotized sulfonylic acid. Diazotized sulfonic acid reacts with N and dimethyl aniline in presence of NaOH. It gives methyl orange. Properties. It is an acidic dye for wool, silk, but it is color faded on exposure of light and washing. Therefore, it is not used as a dye, but it is better used as an indicator in acid-base titration. It is a yellow in basic color, changes in the structure of iron. The basic medium, the ions contains a azochrome, while in an acidic medium it contains a paraquinoid chrome. Our next is 8.5.2 section. Second dye is Congo red. Preparation. It is an example of diazo group. It is prepared by coupling tetradiazotized benzene with two molecules of naphthalenic acid. Tetraazotized benzene naphthalene reacts with naphthanoic acid. It gives Congo red. Properties. It is a red in alkaline solution and its sodium salt dyes cotton to a fuel red. It was first synthetic dye produced which was capable of dyeing cotton directly. Congo red is a very sensitive to acid and a color changes from red to blue in presence of inorganic salt. This depending the color from a red to blue may be attributes to the resonance among the charged canonical structure given below. Our next section is 8.6, that is triphenyl methylane dyes. Triphenyl methane dyes are derivative of triphenyl methane containing NH2 group, NR2 group and OH groups in rings. The compounds so obtained are usually colorless and hence they are also called as leucobases. These are upon oxidation are converted into a correspondence colorless tertiary alcohol or carbinol bases. These carbinol bases radially changes from a colorless benzoate form to the colored quinol form. In the presence of acid due to the salt formation, these changes are summarized given below. That is leucobase colorless oxidation, it gives carbinol base which is also colorless, and it is reacts in acidic medium. We provide acidic medium, it converted into a dye, that is quinoodione dye, structure colorless. Our next section is 8.6.1, that is malachite green. Our next dye is malachite green. The name of malachite green is given to this dye because it has deep blue green color resembling that of malachite and 1 ore of copper. Synthesize. It is prepared by condensation and dimethyl 2 molecules with benzaldehyde 1 molecule at 373 Kelvin in presence of concentration of H2SO4. The leucobase so produced is oxidized with the lead dioxide PbO2 in a solution of CH3COOH and HCl. The carbonyl base so produced reacts with the X's of HCl to form malachite green. Our reaction is when the benzaldehyde reacts with NN dimethyl that is 2 moles in presence of H2SO4 acidic medium, it gives leucobase, and when the leucobase is reacts with or oxidized with PbO2 in presence of CH3COOH, it gives carbinol base, that is almost also colorless. When carbinol base is reacts with HCl and followed by Cl negative ion, it gives malachite green. The malachite green dye wools and silk directly and cotton moderate with the tannin. The color of a malachite green faded slowly when strong acid or a base are added to it. These bases cause the color of the faded because it converts the dye back to the colorless carbinol base. However, in these cases, the acid H positive combines with the lone pair of electron present on N of a free dimethyl amino group. As a result, chances of resonance decreases and the color faded starts. Our next dye is crystal violet, section 8.4.4. Sorry, 8.6.43. Synthesize. It is prepared by heating either of NN dimethyl with carbonyl chloride phosgene or by a Milser ketone with dimethyl in presence of POCl. In first case, Milser ketone initially formed condense further with the dimethyl to form crystal violet. Our reaction is when 2 moles of dimethyl reacts with 1 mole of phosgene, it gives Milser ketone, and after that when it is react with POCl3 and NN dimethyl it gives our crystal violet. Properties. A weakly acidic solution of crystal violet is purple. A strongly acidic solution is green. And still more acidic solution is yellow. These color changes may be explained as follows. In very acidic solution, crystal violet exists in a single charged ion 1. In this structure, two-thirds of the charges can oscillate in the horizontal direction. In strongly acidic medium, the crystal violet exists as a doubly charged ion. Here, the whole unit of charge can oscillate in horizontal direction. The vertical direction of the oscillation is inhibited due to fixation of a lone pair by a proton addition, and hence the color deepens from a purple to green. In a very strong acidic solution, another proton is added to form a triply charged ion 3. In this ion, only little of a resonance is possible, and hence the color lightens from green to yellow. The weakly acidic solution, singly charged ion 1 purple, changes, and in strongly acidic solution doubly charged ion 2 is green of color, and weakly strongly acidic solution, that is triply charged ion, is very little resonance with color yellow. Uses: crystal violet is used in manufacturing of inks, stamp pads, and typing writing ribbons. It is also used as an indicator for determining the hydrogen concentration in a solution. Thank you.